we only one room, right? Okay, this experiment setup. So the minimum requirement in according to X-ray thermal comfort of the room. So our layout is like this. So the room is around 4.6 meter times 3.3 meter width and 2.8 meter height. The room, the measurement equipment is located at the center of the room. Okay, with all the related parameter. So for fan assist, we use a desk fan located at the edge of the building, located of the room. Okay, so why we use this small desk fan located at the bottom? Because one of concern when using fan is we want to prevent the problems of paper flying. So we try to put as low as possible, and then it will projected to the center of the room. Okay, and then the right side shows the some of the sensors. For example, thermal recorded TR72U, which recorded a temperature and relative humidity. And then we have homologer for wind speed sensor, and we have a black globe temperature to measure radiant temperature. Okay, the slide cases, we start with control case with no any ventilation. Okay, just want to see passively how the the room reacts to the external environment. Number two, we set basic temperature 27 degrees Celsius for case 2 and 28 degrees Celsius for case 3 without any fan assist. And then we try to move to specifically 37 degrees Celsius, which varies of fan speed. To be note that for fan speed 1, we measured around 1 meter per second and up to 1.3 meter per second for fan speed 3. And then scale 7 to scale 9, we measured when we set 28 degrees Celsius with using speed 1 until speed 3. Next, for analysis, the two main variables that we consider, which is firstly operative temperature, and then number two, predicted mean volt. Okay, this is thermal comfort sensation by using CBE thermal comfort tools. Okay, but for the operative temperature, we use this equation, which need the input of air velocity, air temperature, and mean radiant temperature. And then for calculate the thermal comfort assessment, we need this assumption value, which is CLO value 0.65 CLO. 0.65 is we obtain from the literature that typically for office room in hot humid climate, we using around 0.65 CLO insulation for office attire. And then metabolic rate, we assume to be sitting and working in office, which is around 1.08. And then when we calculate, we can get this assessment. Okay, so we target, there are 7 scales from cold to hot, but the ideal for comfort is neutral comfort, which is the index is negative 0.5 to positive 0.5. Okay. Okay, next, let's move to the result of case 1, case 2, and case 3. The left side is the operative temperature, and the right side is the PMV, predicted mean volt, which is a thermal comfort assessment. Okay, let's see for case 1, when there is no ventilation and completely passive condition. What happened is the room, especially in block MA UTHM, FKAAB, it will exceed 28 most of the time, and it can exceed 30 degrees Celsius, which is, if we compare to residential house, normally it is around 28 to 29. So this design of office, it can exceed 30 degrees Celsius. The source of heat is mainly from the window and external wall. And then the building envelope itself is unable to provide thermal resistance to maintain indoor air temperature less than 30 degrees Celsius. So if you can see at the right side, the thermal comfort assessment is one PMV1 above, which is hot, slightly warm, hot condition. So the ideal is the neutral comfort zone. This condition. Okay, let's look at case 2 and case 3, where case 2 we set at 27 degrees Celsius and 28 degrees Celsius for case 3. So when we switch on air conditioner, what happened is, of course, the indoor condition is fall under the setting temperature with this building mechanical ventilation system. However, if we see when we set at 27 degrees Celsius, it's quite late to reach steady state, which is after 11 a.m. Then it can reach a steady state condition. But in contrast, we set 28. Sorry, 20. Yeah, okay, 28. It can reach steady state slightly earlier. Okay, probably this is because the conditioner setting. But if we see the thermal comfort assessment, this when we switch on a conditioner without the fan assist is slightly reduced. It can reduce the thermal sensation into uh, fall into the comfort level, but not for so long, not for most of the time. So in this case, some of the cases fall under slightly warm, and only little bit of time that fall under comfort conditions. So basically we can say not enough, okay, to maintain comfort condition for long period, especially around 8 to 6 5 p.m. working hours. Okay, next we look at case 456, where in this case we set 27 degrees Celsius with fan speed 1, fan speed 2, fan speed 3. Okay, similarly with previous, I'm not sure problem or what, but when we set at 27 degrees Celsius, similarly we will start to reach steady state conditions like late around 11. But when we introduce the fan axis, it can maintain very relative low indoor temperature until 4:30 p.m. For all cases. But the problem in this case is uh, all the cases, it tends to be slightly cool. Okay, it means 27 degrees Celsius is very good temperature, but because of fan speed, it will extend the cool condition to slightly cool. All right. Okay,
You have
next
two
we
minutes
look
more,
into case
Dr.
7,
Azwan.
8, and okay, thank you very much. For case 7, 8, and 9, uh, we investigate. Okay, the condition slightly better than the previous cases. So as you can see here, it can reach the steady state early at 10 a.m. And then all the cases shows a very good agreement with the comfort zone, right? So it means 28 degrees Celsius with Fahrenheit is possible to be applied. Next slide shows the summary. So as I mentioned before, uh, at 27 degrees Celsius with fan speed tend to be slightly cool most of the time. The recommended is 28 degrees Celsius with fan speed 1 and 2, where it can reach comfortable hours around 8 hours, right? Lastly, for conclusion for this study, it was found that the most comfortable condition with neutral sensation can be achieved by air conditioning setting of 28 degrees Celsius with airspeed of 1 meter per second to 1.2 meter per second. On another hand, if we want to use a 27 degrees Celsius or 28 degrees Celsius without fan, it can be scheduled earlier during early working hours, but require fan assist ventilation from afternoon to evening. Last but not least, this study shows there is a possibilities to use high setting temperature of air conditioning system with the addition of in providing comfort in the office. So thank you very much.
Okay, thank you very much, Dr. Azwan. So,
Yes.
member of floor, if there is any question regarding the presentations made by Dr. Azwan just now. Okay, either the presenters or the audience are welcome to ask any questions relating to the presentations by Dr. Azwan just now. Is there any? No?
Hi, Dr. Azwan. Maybe I can ask. Yeah.
Yes,
Oh, okay,
definitely. Yes.
Dr.
Yeah. So last time I also do a little bit on my research field is related with urban heat island. So do you
I
think
see.
that yeah? Do you think that the effects, okay, in our country, for example, is it one of the significant factors that affecting the thermal comfort in our country? Do you think in our country it's severe? The case is severe or compared to
Okay,
other developing countries? Yeah.
urban heat island, of course, the common problem now, but it happened in the very big main city. Okay, so for example, Putrajaya, Kuala Lumpur, and JB. So this type of town need to be apa, aggressively to implement the okay, but our country is developed. I say not tidak sekata, not uniform. Some
Mm.
is too fast
Mm.
urbanization, but some still we have some countryside still okay. The environment still okay, but we need to maintain that condition actually, right? So, but it is the urban heat island is actually the main problem, especially in 8 years of I remember 2030 where it is expected that environment will increase 2 degrees Celsius outdoor environment. So we need to prepare how to adapt to that condition.
I
Yeah.
see. All right. Okay. Okay. Thank you. Thank you, Dr. Azwan. Yeah.
Thank you for your question.
Yeah. Yeah.
Okay, thank you, Dr. Nick. But I just have a questions to you, Dr. Azwan. If
Yeah, okay, all right.
if we look at good result, a very good result, okay, all the result is in the comfort zone, okay. But why did you choose 28? How did you choose 28 and 20 at the first hand to conduct the study?
Okay, we choose. Okay, firstly, we want target is to exceed 26 degrees Celsius. So, and the top boundary is we try to follow example from Japan, which already implemented in cool beast campaign 28 degrees
Mhm.
Celsius. So we start
Okay.
from 27 to 28 boundary, which somebody already implement, but there is already implement in different country, different position in the earth, longitude position. So we are slightly near to the apa, Katulistiwa. Okay,
Mhm.
all right. So slightly different in climate. So let's see. We want to see what happened. Okay, but this is just what can I say?
Okay.
Introduction
So it's
study.
based from Japan country.
Yes, yes.
Okay. All right. Is it any other questions? Thank you very much, Dr. Azwan.
All
Is
right,
there any
thank you.
questions from the audience?
No.
No. Okay. If there is no more questions, okay, thank you very much, Dr. Azwan, for the questions. Okay. So I would
All
like
right.
to call upon our second presenter, okay, Mr. Muhammad Amirul Hakim Hassan, okay, from Faculty of Civil Engineering and Built Environment, University Tun Hussein on Malaysia. Okay, and his study is a study of the practical use of green based technology, sustainability, uses